Hello everyone, welcome to the third part of class 11 maths chapter sets. So in this class we will learn the different type of sets, subset of a set and a power set. So let's start with the one by one. So the first part, types of the set. So we know that set is nothing but like this bag. You can see that the collection of all the well defined object, that is called a set. If it is not well defined, then it is not a set. So there are the different type of sets. The first one, it is null set, the basic thing. After that, finite set, infinite set, what is there? What is equal set, subset, and power set? So all these six topics we will cover in this video. So start with the first one, null set. So null means what? Empty, nothing. There is nothing inside the set, that is called the null set. Okay. So null set, or we can say another way, empty set, contains absolutely nothing. For example, one example is given. You can see that a is equal to x such that x is a natural number less than 1. So is there any number which is less than 1 and it is natural? No, because natural number is starting from 1. There is no number which is below 1 in the natural number. So this set is what? Empty set. So how to write empty set? A is equal to, we are writing like this. Okay, either this thing or you can write down this. Okay, not like this, means we never write both, it is combined. This is not a way to write a empty set. Empty set we are writing either like this or like this. This is not a way to write an empty set. Okay, remember this thing. So empty set means there is no element in the set, that is called empty set. Look at the examples. So first, one example already we have seen. This is a second example. X such that x square is equal to 4 and x is odd. Okay, so which element? First of all, this is a set builder form is given. So if we convert in terms of roster form, so x square is equal to 4. So if we solve this, we'll get x is equal to plus or minus 2. Root 4 means plus or minus 2. So we'll get two value, plus 2 and minus 2. And what is one thing, one more thing is given, x is a odd. Okay, so here both the value you are getting, both are even, it is not odd. So that means in this set also there is no element which is there is no element which odd number which satisfy this condition. Okay, that means this set is also null set or empty set. So b is equal to empty set. Look at this set. The question is c is equal to singleton set 0? Okay, set with which has only one element, that is called singleton set. So is this a null set? So answer is no. Why? Because one element there inside the set. Okay, 0 is also an element. So if element is there inside the set, then we cannot say it is a null set. So the C set is not equal to empty set because one element is there. Look at the next D, which is X such that X is the month with 32 days. So is there any month which contains the 32 days? No. So D set is nothing but example of empty set. So D is a empty set because we don't have any month which has 32 days. So these are the example of empty set. If there is no element in the set, then the set is empty. The next, finite and infinite set. Okay, so look at what is the difference between finite and infinite. So in the left side we have finite set. So finite means, you can see, look at the calendar. Finite means countable. The counting process comes to a definitive end. Okay, after some step you will get some end point. Okay, for example 1 2 3 4. So at 30 is the last. Okay, so that last part we can find out here. Okay, so finite set means there is some end in the countable. Okay, for example a such that x is a factor of 12. So what are the factors of 12? 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 6 and 12. Okay, so you can count this, no? Only this 6 factors are there, not more than that. So this is ending here. So this set is finite set. Another way, what is a infinite set? Other side, infinite means it goes on forever, not stopping it is. Okay, so you can never finish counting them. Okay, for example, set of natural number, is there any end? 1 2 3 4 5 6. Can you tell me the last number of natural number? No, it is continuously going on forever. So this is the example of infinite set. So infinite set we are writing like this, dot dot dot, because there is no end here. And finite set you will always end up with some end. Okay, So look at some examples of finite and infinite set. So the first example is here, set of all English vowels. So if we list all the English vowels, that is nothing but A, E, I, O, U. So only that 5 letters, so it is ending here, no? Only 5 elements are there in this set. So this is the example of finite set. The next one, x belongs to natural number such that x minus 1 into x minus 2 is equal to 0. Okay, is this a finite set? Okay, so we have to look at the natural number which satisfy this condition. Okay, so what is the condition given? X minus 1 into x minus 2 is equal to 0. So when the product of two things is 0, whenever either first item is 0 or the second thing is 0, then only the product must be 0, correct? So from here we will get x is equal to 1, and from here we will get x is equal to 2. So both are natural number, so both this element will come in the set. So 1 comma 2. So only two elements are there. Okay, so that is it is a finite set. Next, standard cricket states in the Ranji, India playing Ranji Trophy. Okay, so this is also the finite. Now you can count easily. Okay, so the board sets fixed official number of domestic teams, so we can count this. So this is also example of finite set. Okay, look at some example of infinite set. So first one, point on a straight line. So can you count point on a straight line? If I draw a straight line, can you count? There are infinitely many points on the straight line. Okay, so this set is an example of infinite set. Okay, because between any 2 points there are, if you zoom it, there are infinitely many points between any 2 points on the line. Okay, look at the next example. X belongs to integer. So integer means, keep in your mind, integer means all the positive numbers 1, 2, 3, 4 and so on, including 0, and other side negative number is also there. Okay, so on both the side we are writing dot dot dot, that means there is no end, left side and as well as right side. So all the integer such that x less than 5, x less than 5 means 5 is here, so less than 5 means below 5 whatever integers are there, all the integers we have to write. So below 5 which integers are there? 4, 3, 2, 1, 0, minus 1, minus 2, minus 3 and so on. Is there any end here? So there is no end here. So this is the example of infinite set. Next, multiple of 7. So multiple of 7 means 7, 14, 21, 28. Okay, it is going on. Not last number is 70. Okay, after that also it will 77 and so on. It is going continue. So there is no end here also. So this is also the example of infinite set. Look at the next, that is a equal set. So when we can say the two sets are equal. Okay, for equal set we require the two sets first of all. Okay, so two sets are equal if they have exactly same elements. Okay, so order is not important. Okay, that we know in the last class we have done. So for example, if I write a is equal to 1, 2 and 3, and if I write b is equal to 3, 2 and 1, so can we say these two sets are equal? Yes, we can say a is equal to b. Why? Because a has 3 elements, b has also 3 elements, and elements are also exactly same. In a set 1 is there, in b set also 1 is there. In a set 2 is there, here also 2 is there, here 3 is there, here also 3 is there. Order does not matter, only the number of element and the elements must be same. Okay, so let's, if I take the example, a is equal to, let's say 1, 2, 4, 5, and if I take b is equal to 1, 2, 4, so is this set a and b are equal? Then the answer is no, a is not equal to b. Why? Because 5 element is there, 5 belongs to a, but 5 does not belongs to b. Okay, so when we can say equal, whenever every element of a must be element of b and every element of b must be element of a, then only we can say the elements sets are equal. So look at some examples. So the first set is given a 2 comma 3, so this is a roster form. Second set is given b, this is nothing but set builder form. Okay, so the question is these two sets are equal? So first of all, the set b, which is given to be set builder form, we have to convert in terms of roster form. So this is given to be quadratic equation, x square minus 5x plus 6 is equal to 0. So if we solve this quadratic equation, we will get two roots, x minus 2 into x minus 3. Okay, because the product is here 6. So which two number you will multiply, you will get answer minus 5. So minus 2 and minus 3, correct? Minus 2 minus 3 plus 6 and minus 2 minus 3 minus 5. So the value of x you will get 2 and 3. And in the A set also 2 and 3 is there. In the B set also 2 and 3 is there. That means the set A and set B both are equal. Look at the second example. A set has a element L, O, Y, A, L. Okay, here means two letters are repeated. We have to write down only once. In second set also A, L, L, O, Y. Okay, so in both the set elements are same. Okay, if you write unique way, so in set A can be written as L, O, Y, A. Set B also can be written as A, L, O, Y. So in both the set, L is there, O is there, Y is there, and A is there. That means every element matches and number of elements are also same. So result is A is equal to B. Look at the third question. A set is 1, 2, 3, B set is 1, 2, 3, 4. So it is clear here in the set B one element is extra, which is not there in the set A. So the answer is direct, A is not equal to B. Look at the next part, that is a subset of a set. So what is the meaning of subset? So subsets means a mini version of a set. Okay. So look at this diagram picture here. This is a big doll. Inside that one more is there. Okay. So this small doll is nothing but set A, and this bigger one is set B. So the A set is fully inside the set B. Okay. A set is fully inside the set B. Then we can say A is a subset of B. Okay. Smaller set inside the bigger one. So this is a symbol of subset. So definition is, if every element of the set A is inside the set B, then we can say A is a subset of B. Okay, this is a symbol of subset, or you can write down, or you can read as A is a subset of B. Okay. For example, you can see that set B has an element 1, 2, 3, 4, 5, and set A has an element 2 and 4. So this both the element 2 and 4 which is there in the set A, yes. Okay. So 2 and 4 both the element are there inside the set B, so we can say A is a subset of B. Okay. So one more here note is there, one golden rule you can say. The empty set means nothing is there. The empty set is always the subset of every set. Okay, means empty set is a subset of A, empty set is a subset of B as well as. Okay, empty set is a subset of every set. Next part, look at the examples of the subset. So the first set is given A is equal to A comma B, and the second set B is given to be A, B, C, D. So can is A is subset of B? Question mark. Okay. So just see every element of A. In a set A we have A and B. So both the element is there in the set B. Yes, it is there. So we can say A is a subset of B. Okay. Look at the second example. Write all the subset. Okay. Now this question is where to write down the subset. Subset means parts of that. So A set is given 1, 2. So first part is nothing but empty, because just now we have seen empty set is a subset of every set. So empty set is a sub part of this A. Okay. Then second, we can write down singleton set 1. This is also a part of this set. We can write down singleton set 2. This is also a part of this, and we can write down the full set 1, 2. Okay. So there are two things which is always a subset. Empty set is also already always subset of the A, and A is always subset of A. Okay, empty set and the full set is always the subset of that set, any set. Okay, so the all the subset of 1, 2 is nothing but empty set, singleton set 1, singleton set 2, and the whole set 1, 2. So how many total sets we got, subsets we got for this set? 1, 2, 3, and 4. Total 4 subsets are there of this set. Similarly, look at this true or false statement. This singleton set 3 belongs to 1, 2, 3. So is this true or false? So this is a false result. Why it is false? Because in the middle belongs to sign is there. So if you remember, I told you belongs to sign when we are using belongs to sign only will come between element and a set. Okay. Element belongs to set, but this is here it is written that it is not an element, it is written inside the bracket 3. Okay, if it is written like this, 3 belongs to set 1 comma 2 comma 3, then it is true. In this case it is correct, because 3 is an element, so element belongs to the set. But if it is written singleton set 3, now it is not an element, now it is a set. So set is a subset of the set 1 comma 2 comma 3, not the belongs to. Okay, so this statement is false because here sign is belongs to and here it is set is there. Understood? So relation is what? Between two sets, between two sets, belongs to sign never come. Always subset signs will come. Either subset or not a subset. And between element and a set, always belongs to sign will come. Either belongs to or not belongs to. Okay, remember this thing. Now look at the next and last part of this video, that is a power set. So power set is nothing but a master collection. So master means what? The collection of all the subsets. Okay. So if you look at the definition, power set is a master collection which contains all the possible subsets of the given set. So before start looking the question, just look at the one important note. For example, okay, look at the example first only. So let's say A is 1 comma 2. So what are the possible subsets? Just now we have seen the possible subsets of A are empty set, singleton set 1, singleton set 2, and the full set 1 comma 2. These are the four parts of this set A. Okay, so if you collect all the subsets of the any set, that is called power set. So if I collect this all this, okay, if all these sets, if I write inside the again the set symbol, then this is called power set of A. Okay, this is called power set of A. Look at one more example. If I let's say B set, okay, B set is equal to, let's say, given to be 1 comma 2 comma 3. So what is the power set of B? So power set of B is nothing but one is okay, power set of B we can write down like this, P of B, that is called power set of B is equal to, so power set is also a one set actually, so you have to write down a set bracket. So first empty set will come, after that singleton set 1, after that singleton set 2, after that singleton set 3, then what we can take, we can take 1 comma 2, then 2 comma 3, then 1 comma 3, okay, and then the full set 1 comma 2 comma 3. So all these things are the parts of this set. So how many parts we are getting? 1 2 3 4 5 6 7 and 8. Okay, so these are the power set of B. This is the power set of B. So what is the magic formula to find out the number of element? So look at the first example. In the first example, two elements are there. So how many elements are there in the power set? 4. In the second example, 3 elements are there in the set. So how many elements are there in the power set? 8. So the general formula is, if the set has n element, then the power set has 2 raised to n element. Okay, look at the first example. In the first example, the set A has how many element? 2 element. So the power set of A has how many element? So to write the number of element, we will write n of P of A, which is nothing but 2 to the power 2, because n is 2. So 2 raised to 2, which is 4. So power set has 4 elements. Okay, look at some examples. So the first one, set A is equal to A comma B comma C. So how many elements are there in the set? 3 elements. So what is the formula? 2 to the power n. So n is what? Number of element in the set. So if you apply 2 raised to power n, n is here 3, so 2 raised to 3, which is nothing but 8. So if you write all the subsets, we'll get total 8 elements. Okay, just now we have seen, instead of ABC, 1 2 3 was there. Okay. Now look at the second question. Write the power set of single element. Okay, so only single element is there, that means what is the value of n here? 1. Okay, number of element in the set is 1. So if you apply the formula, so we will get 2 raised to 1. 2 raised to 1 is 2. So only 2 subsets we will get. So which 2 subsets we will get here? One is empty set and one is the set itself, singleton 5. So these are the two power set of B, or two element of the power set. Okay. Now look at the third, and this is an important question. How many elements in the power set of empty set? Okay. So if the set is given like this, C is equal to empty set. So inside the set it is already nothing. So what is inside the power set? So in the set there is no element. So there is no element, that means what is the value of n? 0. Okay. So if you apply the formula, it becomes 2 to the power 0. Okay. So 2 raised to 0 is nothing but 1. Okay. Any number, non-zero number raised to 0, which is nothing but 1. So that means power set cannot be 0 anyway. In the power set, minimum one element must be there. Okay. And that is itself empty set. Okay. So power set always has one element, even if the set is empty. Now look at one example I will give you. Let's say if B is equal to given A comma B. So what is the power set of B? So power set of B is nothing but first is empty set, second is singleton set A, third is singleton set B, and the fourth is the whole set A comma B. Okay, so this is the power set. Power set is collection of all the possible subsets. Empty set is a subset of B, a singleton set A is a subset of B, singleton B is a subset of B, and the whole set is also a subset of itself. Okay. So this is about the power set. So look at the ultimate clean sheet. That null set, how to denote like this. Finite set means countable. Infinite set means it is not ending, there is no end of that. Equal set like this. Subset means this is a symbol. And power set, so to find out the number of element of power set, the formula is 2 to the power n. Okay. So if you like this video, then share with your friend and don't forget to subscribe. Thank you.